Welcome back to the Organic Chemistry of second year. So we were studying the topic alcohols. Now let us see some general methods of preparation. General methods of preparation of alcohols. Preparation of alcohols. So let us consider one by one. There are a variety of methods available for the preparation of the alcohols. The first one is from alkyl halides. Alkyl halides. When these alkyl halides are treated with by the action of aqueous potash. Remember, when potassium hydroxide is used in the aqueous medium, it is called as the aqueous potash, which replaces the halogen atom by the hydroxy group. So in general, we can write this Rx plus KOH, aqueous, giving rise to ROH plus KX. For example, if you consider this ethyl bromide, CH3CH2Br, when you treat this with potassium hydroxide in aqueous medium, then it will give rise to CH3CH2OH along with this potassium bromide. Then coming to the second method from carbonyl compounds. Carbonyl compounds. These carbonyl compounds are the compounds which contain C double bond O as a functional group. Say for example, if you take a compound with CHO group, it is called aldehyde. So we can take aldehyde as a starting compound. Or we can take this C double bond O, that is ketone. Or we can take this C double bond O, OH, that is acid. Or we can also consider this C double bond O, OR dash, that is called an ester. When these compounds containing the C double bond O group is subjected to reduction, that is by reduction. This reducing agent we can use is lithium aluminium hydride, or we can also use this sodium and alcohol. Sodium and alcohol. The reduction by using this sodium and alcohol is called as the Bhogesh-Blank reduction. Bhogesh-Blank reduction. Specific sodium and alcohol used as a reducing agent. Such a reduction of the carbonyl compound by using this reagent is named as the Bhogesh-Blank reduction. Depending on the required alcohol, we have to start with the corresponding aldehydes. Suppose you take this formaldehyde, it gives rise to methanol. If you take this acetaldehyde, it gives rise to ethanol. If you start with acetone, it gives rise to 2-propanol. So let me write, for example, CH3CHO. If this is subjected to reduction either by using lithium aluminium hydride or by using sodium and alcohol, it gives rise to ethanol, CH3CH2OH. Similarly, when you start with this acetone, CH3C double bond O CH3, same reduction, it gives rise to CH3 CHOH CH3, 2-propane 2-ol. Propane 2-ol. Suppose you start with propion aldehyde, it will give rise to propane 1-ol. Suppose I take this CH3COOH. This on reduction will give rise to ethanol, CH3CH2OH. If I use this CH3, COO, C2H5, ethyl acetate. This again gives rise to CH3CH2OH, actually 2 molecules. One due to this CH3COO group, the other one due to C2H5 group. So we have these 2 molecules of ethanol. If you change these carbon atoms in the ester form as well as the acidic form. Then we will get mixture of alcohols. So this is, for example, if you take this CH3COOCH3, methyl acetate, on reduction it will give rise to ethanol, one molecule, plus methanol, another molecule. Mixture of alcohols we will get. So this is the second method. Coming to the third method, we can use Grignard reagents. Grignard reagent. When this Grignard reagent is treated with an aldehyde or a ketone or an acid or an ester, etc., again they will give rise to corresponding alcohols. Here we have to carry out the reaction in two steps. First we have to treat the carbonyl compound with Grignard reagent. Then we have to subject it to hydrolysis. I will give one example for each of that. First, if you start with this formaldehyde. If you take this Grignard reagent, any Grignard reagent RMgX, this R group will undergo addition reaction to this carbonyl group, so that MgX will go to the oxygen while R group will go to the carbon. So we will get RCH2OMgX. This is an intermediate compound. This, when treated with the water, it will give rise to corresponding alcohol, that is primary alcohol. Along with this MgOHX. The reaction first is carried out in the dry ether medium, because Grignard reagent is soluble in ether, and it, in the ethereal solution only it will undergo reaction with formaldehyde. This HCHO, formaldehyde, will always give rise to primary alcohol. Suppose I take this CH3CHO, any other aldehyde, acetaldehyde, propianaldehyde, etc. Then if you treat this with R's MgX, it will give rise to RCH3OMgX. This on hydrolysis will give rise to RCH3OH. This is exclusively secondary alcohol. Formaldehyde will exclusively give rise to primary alcohol, while any other aldehyde will give rise to the secondary alcohol. Then coming to the next one, if I take a ketone, for example, if I take this acetone, CH3, C double bond O, CH3, treat with this Grignard reagent RMgX. Let me write this as A, B and C. It will give rise to, in ether, it will give rise to R, C, O, MgX, CH3, CH3. Remember, this CH3, CH3 come from the ketone, while R group will come from the Grignard reagent. And this on hydrolysis will give rise to R, COH, CH3, CH3. This is exclusively tertiary alcohol. Just I will repeat. To get the primary alcohol, you treat a suitable Grignard reagent with formaldehyde. To get a secondary alcohol, you react this with any other aldehyde, suitable any other aldehyde. While to get the tertiary alcohol, you treat the ketone with the Grignard reagent. Ketone should be selected in such a way that what the needed alkyl groups are present in that one. One more thing is, when you take this carboxylic ester, RCOOR dash, when you treat this with another Grignard reagent carrying the alkyl group R double dash MgX, then it will undergo reaction with the two molecules of this one, so that two alkyl groups of the Grignard reagent will add on to this carbon oxygen double bond. So it will give rise to R COMgX R double dash R double dash. This R dash group will go as R dash OH, and this on hydrolysis will give rise to R COH double bond R double dash R double dash. This is again a tertiary alcohol. To conclude this one, with the Grignard reagent we can prepare either primary, secondary or tertiary alcohols using a suitable carbonyl functional group compound. Formaldehyde will exclusively give primary, any other aldehyde will give exclusively secondary, while the ketone group or ketones or the esters will exclusively give rise to the tertiary alcohols. Suppose I want this CH3, COH, CH2, CH3, CH2, CH2, CH3. You can start from either CH3, CO, CH2, CH3 as a starting compound ketone. Then this alkyl group must be present in the form of Grignard reagent. Or you can select this CH3, CH2, O, C double bond O, CH2, CH2, CH3 as a ketone. Then CH3 MgBr should be used as a Grignard reagent. So depending on the requirement, we can select either ketone or any other aldehyde or formaldehyde. Suppose I want this CH3, CH2, CH2, CHO, CH2OH. Since it is a primary alcohol, this should be present in the form of formaldehyde. The remaining 3 carbon atoms should be present in the form of Grignard reagent. So I will take this CH3, CH2, CH2 MgBr, and this one I am taking as HCHO. So depending on the requirement, we have to select the aldehyde, formaldehyde or any other aldehyde, ketone or an ester. In all these reactions, one common method is involved, common process is involved. RMgX will be polarized like this. R will carry negative charge, Mg will carry positive charge because magnesium is a metal. And this R group will go to this carbon atom while MgX will go to the oxygen atom. So addition reaction takes place to give rise to this intermediate compound, which on hydrolysis will give rise to the corresponding alcohol. There are so many other methods also that we will take up in the next video. Thank you.